Okay. Good morning. This is Professor David J. De Los Reyes. Okay. My topic for this session will be a little bit of algebra and analytic geometry. Okay, let's proceed. I will try. We are given a problem. I will try to read the problem. What type of analytic figure does the equation y equal to x represent? Represent or represents? Okay. We are given the equation y is equal to x, and the problem is asking what type of analytic figure. This should be an analytic figure. We are on the topic analytic geometry. It involves the Cartesian coordinate system. We got the y-axis and the x-axis. It's only a plane, okay? And that is termed to as the so-called Cartesian coordinate system. This is the x-axis, this is the y-axis. And the problem is asking what analytic figure does y equal to x represents. If we try to bring out the solution, y is equal to x. So it seems we are given y as a function of x, right? Right? The highest power of y on the left-hand side is actually 1. And the highest power of x on the right-hand side is also 1. 1 is termed to as linear. It is linear. It's a linear equation. If it is with the power 2, it will be a quadratic equation. And since the power of y and x for both the left and right are both 1, it is linear. So meaning, it represents, we remove this ER here, it represents a straight line. So I place it here. Since the power of y and x for both the left and right are both 1, okay, the equation y equal to x represents a straight line. That will be our answer. And to grab our answer, it is an easy matter in analytic geometry. We use the so-called point plotting. For a linear equation, we only need 2 points for us to draw a straight line, right? But actually, I presented 3. From the equation y equal to x, point plotting, when x is equal to 0, y will be equal to 0. Using this equation, when x is 0, y will be 0. That's our first value. Our first point is actually the origin. When x is 0, y is 0. We are at the origin. So meaning the equation y equal to x passes through the origin. Okay? Point number 2. When x is equal to 2, y will also be equal to 2. So the second point is actually, so for this equation, whatever value we place for the value of x, y will follow. So actually, it does not vary. So this is so-called straight line. It does not vary. Vary meaning like it will go like that, right? But for a straight line, it does not vary, right? So whatever value for x we will place, y will follow. Okay, I will try to erase this one so it will look good. Where's my pen? Okay, we'll continue. So the second point is actually this point here. 1, 2, it goes up, right? When the value of x is equal to 2, 1, 2, the value of y is also 2. This is 1, 2. So the intersection of the horizontal and vertical line represents the second line. So this point here is with coordinates 2 and 2. Okay, we need additional points. Anyway, it's a straight line. When x is equal to 4, y is also equal to 4. So when x is 4, this 1, 2, 1, 2, 3, 4. This is actually the line. Right? and y will also be 4. So this is 1, 2, 3, 4. So the intersection of the vertical and horizontal line represents the third point. And the coordinates of the third point is actually with coordinates 4 and 4. And actually, to bring out the figure, we need the, what they call this, to bring out the figure, we need to bring out a straight edge. So we connect 0, 2 and 2, and 4 and 4. So we'll just do like this. Okay, then just connect it. So the equation y is equal to x is actually this line here. Okay? I just presented the graph for us to visualize our answer. So the problem is asking what kind of graph analytic figure does y equal to x represents. It is a straight line. Okay? So our topic for tonight is actually analytic geometry in combination with algebraic equation. Good morning from Los Angeles.